this packet tracer, we are going to see how to configure a single area OSPF version 2 configuration. This is our addressing table. Objectives: implement a single area OSPF version 2 in both point-to-point and broadcast multi-access networks. Background: you are helping a network engineer test an OSPF setup by building a network in the lab where you work. You have interconnected the devices and configured interfaces and have connectivity within the local LANs. Your job is to complete the SPF configuration according to the requirements left by the engineer, which I am an engineer too. Use the information provided and the list of requirements to configure the test network. When the task has been successfully completed, all hosts should be able to ping the internet server. Our internet server, which is this one. So all hosts should be able to connect the internet server. I can see we have here the headquarters, this network, and the data services, OSPF area 0. Instructions: configure the network to meet the requirements. Requirements: use process ID of 10 for SPF activation on all routers. Activate OSPF using network statements and inverse masks on the routers in the headquarters network. So in the headquarters network, we are going to use the network statement and inverse mask. Because there are basically 3 different ways for us to configure the OSPF. Basically, we can configure SPF by creating the OSPF process in the router, and then we can advertise specific network and the wildcard mask, or we can advertise the specific interface, and then the router, the OSPF process will advertise the network that is associated with that IP address. Or we can go to each different interface, and then we can in the interface advertise the OSPF process. Now they want us to configure using network statements and inverse mask. So it's going to be router SPF 10. We can see our directly connected routes. Don't forget that we have to use here the wildcard mask, and there it's going to be 0. Not the other network. And last network, 12. Done for this one. Let's go to another. So it's going to be the same to advertise each directly connected network. The other network. Establishing the adjacencies. And you have to always calculate the wildcard mask, which basically it's the inverse of the subnet mask. And our last network. It's done. Last router. Area 0. And dot 3.0 dot is going to be /28 255 minus 240. Okay, it's going to be dot 15 area 0. Okay, and it's done for these routers. Okay, next, activate OSPF by configuring the interface. Okay, we can do something here. Okay, if you use this process, this show command, you can see the state that has been established with the other routers. Okay, the neighbors, and it's working. Okay, it's in full state. Okay, now activate OSPF by configuring the interfaces of the network devices in the data service network where required. Okay, here they want us to, by configuring the interfaces of the network devices. Okay, so they want us to implement OSPF in the specific interfaces. Okay, configure router IDs on multi-access network routers as follow. Okay, the router IDs. Okay, so we go to this one. Configure router OSPF 10. Configure router ID. Okay, exit. So we use the show IP interface brief. Okay, interface gigabit 0/0/0, and here we use IP OSPF. Okay, process. Okay, which is going to be 10 area 0. Okay, and it's done. And we have to do the same for the other interfaces. Okay. Well, there's a thing here that there's no need for us, and we shouldn't advertise this last interface. Okay, because this interface is connected to the internet. Okay, it's not a private IP address, so this interface we can issue. Okay, we are not going to advertise this network. Okay, now let's go to the other routers. Now router 2. Okay, now the router ID. Okay, now we are going to interface. Type interface brief. Now the other interface. And that's it. Last router. Router ID is going to be 4.4.4.4. Interface. Okay. Area 0. Okay, and that's it. So we have configured these 3 routers, okay, for the data services. Now configure SPF so that routing updates are not sent into networks where they are not required. Okay, we shouldn't send the updates to to the LANs, okay? And we shouldn't send the updates to the internet. So we go to this one. We use the to see our interfaces. Okay, we shouldn't send the updates through these 2 gigabit interfaces, so we use passive interface gigabit 0/0/0. Okay, now for this router, the same. Okay, now this router it's the gigabit 0/1. Okay, it's the other interface. I was seeing the interface of the switch. Okay, now okay, it's the same. Okay, and now here in this router we have to put the passive interface, this one, the one that connects to the internet. For security reasons, for example, we should put as passive. Okay, that's it. All the others, they should send the updates, okay, because they are connected to routers. Now configure router PC1. It's this one here, PC1, with highest OSPF interface priority, so that it will always be the designated router on the multi-access network. Okay, priority has to be configured in the specific interface. Okay. Router is going to be IP OSPF priority. This is the highest priority. Okay, you can see this is the highest priority. Now configure a default route to the internet service provider cloud using the exit interface command argument. Okay. It's going to be we have to configure a static route. Okay, default static route through the exit interface. Okay. Automatically distribute the default route to all routers in the network. Okay, so for the all routers to receive the default gateway through the updates, we have to go again to router OSPF process. Okay, this is the okay. No, it's not this one. Sorry, it's the okay. It's default information originator. Okay. Now it starts propagating default gateway. example. Okay, as you can see, this router, he had this route through the OSPF process, and this symbol here means that it's a candidate of default gateway, and it's true. Here it is. Okay, so it's configured correctly. Next, configure the OSPF routers so that the gigabit Ethernet interface cost will be 10 and the fast Ethernet cost will be 100. Okay, this is designed for fast Ethernet links. So in the router process, we have to configure the auto cost, reference bandwidth, and then this is in megabits. So we have to put 1000. Okay, 1000 megabits, which is 1 gigabit. So the it's 100. Okay. Oh no, sorry. That it was this. Okay. Okay. In this way, what happens? The gigabit interface cost will be 10. Okay, and fast Ethernet cost will be 100. Okay, now we have to do the same for all the others. Okay. Okay, this is configured. Now, configure the SPF cost value of P2 P1, is this one, interface serial 0/1/1 to 50. Okay, so we have to go to the specific interface. OSPF cost 50. Now, configure the hello and dead timer values on the interfaces that connect P2, P1, and BC1 to be twice the default values. Okay, twice the default values. So the default values for the hello time is 10 and dead time is 40. So it's going to be 20 and 80. Okay. It's this interface. No, let me check. No, it's going to be interface serial. Okay, the OSPF hello interval 20. Okay, and the OSPF dead interval 80. Now the same for the other router. Okay, this is the interface serial 0/1/0, IP OSPF hello 20, and the IP OSPF that time 80. Okay, Well, I think that's all. But we can check here to the things to see if everything is okay. Okay. Okay, it's working. Okay. I didn't get it. What was the problem? At the first time, I don't know if network has converged or not. I think it already has. Sometimes it's packet tracer problems. Let's see another. Okay. So everything is fine. Well, I think that's all. Thank you.